Before you start Lesson 46, make sure you complete Test J in the Test Masters on operations with decimal numbers. In Lesson 46, we'll be covering the three topics listed here: unit price, rate, and sales tax. Remember, I've discussed before that I think the two most important reasons for mathematics and the reasons God gave us mathematics are as a tool to help us study His creation and therefore to know Him better, and that really means through a study of science, and then also as a way to interact with other people. And one of the ways we interact with other people a lot is different money values, that we need to buy or sell something and there's some particular monetary value applied to that. For example, look at practice problem A. It says, what is the unit price of a 16-ounce can of corn that costs 88 cents? Unit price, that's something very important to be able to do. And one of the main things for that is so that you can compare different items and see which one might be cheaper. So if you had a can of corn that cost 88 cents, it was 16 ounces, what you need to do to find the unit price is the price per unit. In this case, that's ounces, so the price per ounce. All you do is division. You would just say 88 cents divided by 16 ounces to get a price per ounce. So whenever you're finding unit price, you're putting the money value, whether it's cents or dollars, you put that on top, and then the unit that's involved here, in this case ounces, sometimes it might be liters or gallons or pounds, you put that in the denominator. And just do the division now. Don't worry about the units. 16 would go into 88 5 times. Have an 8 left over. Now we need to put a decimal point in here and bring down a 0. 16 would go into 80 exactly 5 times. And so there's our answer, 5.5. But there are units involved here. 5.5 cents per ounce. 5.5 cents per ounce. For every ounce of corn, it costs 5.5 cents. Now, here's one of the main reasons you would want to know how to find unit price, is to compare to another item that you might be wanting to buy that's similar. And look at B. It says, is this a better buy? So in other words, is 5.5 cents per ounce, our answer in A that I'm circling right now, is that a better buy than a 20-ounce can of corn that costs $1.12? Well, what we need to do again is find a cost per ounce. We have 5.5 cents per ounce, but we have dollars here, $1.12 per 20 ounces. Just change that to cents, and we'd have 20 as our divisor and 112 cents. 20 goes into 112 5 times. And we need to put a decimal point in there, add a 0, bring that down. 20 would go into 120 exactly 6 times. So now we have 5.6 cents per ounce. That's what this 20-ounce can cost, 5.6 cents per ounce. So no, that's not a better buy than 5.5 cents per ounce. Make sure you answer the question correctly. The question is, or the answer to the question is not 5.6 cents per ounce. The answer is no. Because that's the question, right? Is this a better buy than a 20-ounce can that costs $1.12? And actually, I'm not answering the question correctly. Yes, 5.5 cents per ounce is a better buy than a 20-ounce can that costs $1.12, because a 20-ounce can that costs $1.12 is 5.6 cents per ounce. 5.5 cents per ounce, that's the part, or that's what we got for A, that is a better buy. Unit prices, a lot of times if you go to the grocery store and you look closely, you'll notice that they have the unit prices there next to the main price for a particular product. Most halfway decent grocery stores do that. And that's a great way for you to tell which brand or which thing is the best value. Now, you may go to the store and think you're doing really good and you're really smart because you used this unit price method and you found the thing that was the cheapest per ounce or the cheapest per gallon and you bought that. But then you go home and it tastes really nasty. So sometimes just because you buy the thing that's the best unit price value doesn't mean it's going to taste good or you're going to like it. So looking at unit prices and knowing how to calculate unit prices is one way to help you make good buys when you go to the store, but it's not the only thing that you need to look at. Cheapest doesn't necessarily mean best. So just to review here, whenever you have to calculate a unit price, whenever you're asked to find a unit price, you always put the money in the numerator. That's your numerator, and then the other unit is your divisor or denominator. Now let's talk about rate. Rate is another fraction type of problem. It's really a whole lot similar to unit price, where you have a numerator and denominator and you have different values in the numerator and denominator. Unit price, you always have money in the numerator and some other unit in the denominator. Rates, they are just comparisons of two different units. And look at practice problem C. The Edwards drove 311 miles in 5 hours. What was their average speed? Well, hopefully you're familiar with a speedometer on a car, and you usually know that a speedometer is in units of miles per hour or maybe kilometers per hour. That's a fraction or a rate. And think of ratio. We've talked about ratios already. The word rate and ratio sound a whole lot the same, don't they? So that should help you think of fraction when you're looking at these problems. So when you think of speed, you should think of miles per hour. That's just a very common thing in your life. If you drove 311 miles in 5 hours, the speed would be 311 miles per 5 hours. So you have a fraction there, which you can simplify doing division. And so let's just go ahead and do that. We don't just want to leave it 311 fifths. We would say 300, or put 311 in for the dividend there. And 5 goes into 31 6 times. 5 goes into 11 2 times. Now we need a decimal point there. Put a 0 in here. Bring down a 0. 5 goes into 10 exactly 2 times. And there's our answer, 62.2. Now we need to write our units as well. Miles per hour. That word per, that represents our fraction bar. We had miles in the numerator, hours in the denominator. Just like on our unit price problems, we always had dollars or cents in the numerator, some other unit in the denominator, and we would say dollars per ounce, cents per ounce, or just whatever it was. But that per, that's our fraction bar. That's how we write our fraction bar using a word. 62.2 miles per hour was the Edwards average speed. Look at problem D. The Hummer drove 324 miles on 30 gallons of gas, which is an average of how many miles per gallon? So think about the question that they're asking here. How many miles per gallon? Hopefully by now you're recognizing that that means a rate or a fraction, miles per gallon. You have been given 324 miles and 30 gallons of gas, so you should be able to just do a division problem there to figure out the miles per gallon. A lot of times rates deal with an amount per unit of time, like miles per hour, feet per second, things like that. But rate does not have to have a unit of time in the denominator. Here, our gas rate, our gas consumption rate, is miles per gallon. So let's just go ahead and do the division here. Kind of running out of room. 30 goes into 32 one time. 30 goes into 24 0 times. We need to add a decimal place there, bring down a 0. 30 would go into 240 exactly 8 times. So there's our answer, 10.8, and I'm just going to abbreviate this. Instead of writing the words miles per gallon, I'm going to write MPG. Maybe you've seen that before on a commercial, or maybe you were shopping for cars with your parents or something, and you saw that the gas mileage was on the sticker on the car, and it would say this much MPG, miles per gallon. On unit price and rate problems, the units are really important, so make sure you put those down. Let's do one more rate problem. This one is an exchange rate. The question is, what was the exchange rate if $35 were exchanged for 1,365 francs? Now what I want you to do is write this as francs per dollar and also dollars per franc. You can write rate problems. It doesn't matter sometimes which way you have the units, whether the dollars are on top or on bottom. Usually what you do on a problem like this where they want the units written in two different ways, or have the rate written in two different ways, is you have the larger number as the numerator first, and then you can kind of get a unit price on it, and then you can just flip it around to get the other rate. So let's do 1365 francs per $35. We'll do that first. $35 goes into 136 3 times. We'd have 105 as a product there, and we'd end up with 31, bring down a 5. 35 would go into 315 exactly 9 times. And so our rate here is going to be 39 francs per dollar. And the other way, we can write this as dollars per franc. And so we would say 1/39th dollar per franc. So there's two ways that we can write a rate like that. And usually in the problems they'll ask you to write it two different ways. The first thing you should do on a problem like that is have your numerator as the larger number and get kind of a unit price. 39 francs per dollar, that means 39 francs for every single dollar, every $1. So you just flip that around to get the other way to write the rate, 1/39th dollar per franc. 39 francs per dollar is 1/39th dollar per franc. Or it means that there's 1/39th of a dollar for every franc. Look at F. If the sales tax was 8%, what was the total tax on a $12.95 t-shirt and a $6.95 map? Now when you're working with sales tax, you're usually dealing with a percentage. And what you need to do to figure out a tax amount on a certain value is to multiply by the decimal form of that percent. So 8/100ths or 0.08 times that dollar value will give you the total tax. So let's just go ahead and do that. On this particular problem here, first we need to figure out the total of the purchases. We had a $12.95 t-shirt and a $6.95 map. So we need to add those two things together and then multiply by 8%. So let's just do a little bit of division first. Anytime you rewrite numbers, just make sure you're writing them the same. $12.95 and $6.95, we're adding these things together. $19.90 is our total. Now we need to multiply that by 0.08. So we say 0.08, because that's what 8% is, right? 8%, 8/100ths. Now we want to ignore our decimal places for now, right? Let's just over to the side say 4 dp to remember that we'll need 4 decimal places when we're finished. And just think about this, we're really doing 1990 times 8. And so we'd have 8 times 0, 8 times 9 is 72. 9 times 8 is 72 again, plus 7 would be 79. And then 8 times 1 is 8, plus 7 is 15. 15920. Now we go back in and we move the decimal place to the left 4. 1, 2, 3, 4. 1.592. Now there's an interesting number when we're dealing with money, 1.592. What we need to do is round that to the nearest hundredth. Now a lot of times, depending on the cash register, it might just round that up to $1.60 so that they don't lose 0.02 of a cent. But for our purposes here, we'll just say that that's $1.59. That's the sales tax. And go back and look at the question. If the sales tax was 8%, what was the total tax on a $12.95 t-shirt and a $6.95 map? It would be $1.59. That's the total tax. 8% of 1990 is $1.59. Now usually when you go to the store, you're not really concerned that much about what the tax was. You want to know what the total cost is. That's the thing that you're going to be paying for, is the price of your items that you bought plus the tax. And so in problem G, I want to know how much was the total purchase, including the tax. So what we would do is say 1990 plus $1.59. And so you go ahead and just do your addition here. Get the decimal place. $19.90 plus $1.59 is equal to $21.49. That's total purchase would be $21.49. Let's do one more problem. Whenever you go to a restaurant, the standard tip is, or tipping rate is about 15%. So 15 per 100, that means $15 for every $100 of food purchased. So look at this problem here. After paying a restaurant bill of about $18, James left a tip of 15%. How much money did James leave for a tip? Now, we can just multiply $18 by 15%, or 15 hundredths, which would be 0.15, and that would give us our amount of money James left for the tip. So we just say $18 times 0.15. We don't worry about our decimal places right now. Just go ahead and do the multiplication here. And then that was 5 times the 1800, and then 1 times 1800, we would just end up with 0081. Go ahead and add these together. And move the decimal place over 2, or over 4, I mean. We'd have 2.7000, or $2.70. So that's the tip that James left, $2.70. Now one thing that I do whenever I leave a tip is I think of that rate, that 15% rate, and you can think of 15 per 100, or most of the time you're not spending $100 for food, so a better way to think of it might be 1.5 per 10. $1.50 for every $10 of food. On a problem like this, what you could do is just kind of round $18 up to 20, and if you gave $1.50 tip for every $10 of food, then you spent about $20 on food. That means about a $3 tip. Here we did it exactly. We got exactly $2.70. you may not have a calculator or a piece of paper and a pencil to calculate this exact tip on, and you may not have 70 cents worth of change. You may just have $3 bills, and so you can just estimate how much your tip is going to cost by knowing that for every $10 worth of food, you should give $1.50 worth of tip. So sales tax and tips, the way you calculate how much those are is you turn that percentage into a decimal and then multiply that by the total dollar amount. That gives you your amount of sales tax or your amount of tip that you need to pay. Okay, well that's all for lesson 46.